In this video, we're going to be talking about tank drive and how to write some code that makes our drive base move at a very slow output speed. So what I want to start off this video with is this CAD of one of our drivetrains from 2022 and just talk about, how it works, how everything's laid out, etc. So you'll notice that with the tank drive, at least the ones that we build as a team, there are three wheels on the left, three wheels on the right, and three sets of motors, or rather a group of three motors that controls each side. And so what we want to do in code is get these motors to move at a slow percent output, so we want to move all six of them. And what I also want to talk about is how we set up our motors to move, because what you'll eventually realize is that we could make this code pretty complicated, or we could make it a little bit easier by just doing some quick motor setups. So the first thing that we're going to do is head over to our project. And again, this is the same project that we worked with in our previous video. And what I want to do is create 6 new motor objects. Now, when I create motor objects, at least for a tank drive base, I like to use a specific naming scheme, and I think you'll appreciate it as well once we talk about some of the motor setups that we need to do. So the first thing is I'm just going to rename this to left side primary. And I'm going to assume that the motor IDs for our drive base are 1 through 6. And again, you can set that up in Phoenix Tuner or double check if that's the case. Now, the next motor I'm going to create, again, we need 6 of these, is going to be called left side 1, capital X, left side 1, those new Talon FX, ID 2. And then we're going to do the same thing, private Talon FX, left side 2, this new Talon FX, and then 3. Not 30, 3. Okay, now we've got the left side done, so I'm going to do the right side. So I just going to copy this, make it a lot easier, and just change all these three. And this is going to be ID 4. This is going to be ID 5. And this is going to be ID 6. Now you're probably already wondering, if we scroll down to where we wrote our last motor spinning code, and again, motor.set, we don't have a motor named motor anymore. I'm just going to comment this out for now. You might be wondering, well, if we have 6 motors over here, does that mean I have to write this set thing for 6 motors? So I have to write this 6 different times? The answer is you could if you really wanted to, or we could talk about doing some of those motor setup things that I was talking about earlier to make our lives a whole lot easier. And that's exactly what we're going to do. So what you'll notice is that in our tank drive setup, we have 2 groups of 3 motors each. And each group of 3 motors is actually doing the exact same thing. So rather than code the exact same thing to a set of 3 motors, why don't I just code one motor and have the other 2 motors follow the one motor that I'm sending a command to? And that's exactly what the Talon FX library allows us to do. So what I'm going to do first, and what I recommend doing anytime you want to set up any following, etc., is config the factory default. What that means is just wiping any previous configuration on the motor and starting with a clean slate. So in order to do that, we do left side primary config factory default, and we can do this for every single motor. So left side 1 config factory default, and then left side 2 config factory default, and then we can do the exact same thing but for the right side. Again, just changing all these to right. Okay, so what you'll notice is that one of these, and why you'll appreciate the naming scheme, is that all we're going to have to do eventually in code is just send an output to left side primary and send an output to right side primary, and left side 1, left side 2 will follow left side primary, right side 1, right side 2 will follow any command sent to right side primary. And so usually we can pick any one of these 3 motors to use. It's entirely up to you. And so what we're going to do in order to do that is just tell left side 1 and left side 2 to follow left side primary, and tell right side 1 and right side 2 to follow right side primary. So what we're going to do is left side 1 dot follow left side primary, and then we'll do left side 2 dot follow left side primary. And then we're going to do the exact same thing for the right side. So right side 1 dot follow right side primary, and then right side 2 dot follow right side primary. Okay, now that we've set up our follow, there's one more thing in terms of setup that we actually need to do that's pretty important. So one thing that you'll notice in this diagram is that if you actually think about rotating a wheel, and let's say you went to this right side over here, right? You grabbed this wheel and you started rotating it clockwise, all right? Now let's say you went onto the other side. So if we moved, or before I go on the other side, if we moved this clockwise, right? That means our drive base is going to go in this direction, right? So a clockwise movement this way will result in our drive base going that way, right? At least in terms of this side. Now let's say I wanted to mimic the same, now let's say I'm looking at the left wheel, so I'm facing this perspective, right? And I want to rotate clockwise. Well, a clockwise rotation is this way. And if we think about it in terms of what side we're on, if I rotate clockwise, that means the drive base is going to move this way. And notice we've got opposing directions. So that means that if I was to command both motors right now to go at an output of 0.1, then the robot's actually just going to start pivoting in place. So what we need to do actually is invert one of the sides so that the output is inverted, and we, by sending the same output value to both sides, it will go in the direction that we want it to go. So in order to do that, we're going to head back over here. And what we can do, and you can pick either side, left side or right side. For now, I'll pick the right side. And what we can say is right side primary dot set inverted, and we need to specify an invert type. So we're going to type in invert type, and we're going to invert the motor output. So whatever value that I send to right side primary, the code will automatically invert it. And that's really useful because now we don't need to worry about what value we're passing in. We can just pass in the same value and be assured that the robot will follow that as needed. Next thing that we're going to do is, and what I like to do rather, is it's a little bit redundant, but I just want to make sure that all of our motors on the right side are actually inverted. So what you can actually do is say right side 1 dot set inverted invert type dot follow master. And we can do the same thing for right side 2. And this will make sure that it has the exact same invert scheme as right side primary. Okay, so now that we've set up all our inverts correctly, now that we've got all the following done, all we need to do inside teleoperiod, I'm just going to get rid of this line, is say left side primary dot set. We can do a control mode for percent output 0.1. And remember, we want to move both of these motors at the exact same time, which is why it's critical that we get the exact same values set up as well. Because if you want to move straight, right, we want to make sure that both the left side and the right side are moving the exact same speed. So that's why the invert there was important. That's why we need to specify our values for both the left side and the right side. So we're going to do right side primary dot set control mode dot percent output and 0. Now at this point, you might be wondering, well, in our previous video, we talked about percent output having a range between -1 and 1. So why did we need to invert this? Or why didn't we just add a negative to this side instead of doing this whole invert thing? Well, for me, it's more of just a code comprehension thing, because when I imagine a robot going forward, I imagine that the left side and the right side are being actuated at the exact same speed. And when you look at the code, you also want to verify. So if I was to look at this, just this part right here, then I can think, okay, both the left side and the right side are moving at the exact same speed. But if I added a negative here, it's going to be a little confusing in my head because I'm going to try to picture the left side moving at one speed, but then the right side moving at the same speed but in the opposite direction. That gets a little confusing. So that's why inverts are nice, because they allow us to write code that actually makes human sense, as opposed to just slapping on a negative because it just makes the robot work. No, we want to add some level of human comprehension within our code as well. So go ahead and test this. Just remember that we're not using any joysticks right now, so the second you enable IntelliOp, this robot will move forward, so keep that in mind. And yeah, we'll see you in the next video where we talk about adding joystick control with our drive base. Thanks for watching.